Welcome everyone. We've just read the first 6 verses of Hebrews chapter 11, culminating with these words, "And without faith it's impossible to please him, for he who comes to God must believe that he is, and that he's a rewarder of those who seek him." He who comes to God must believe that he is. But what if that isn't you? What if you don't believe that God exists? What if you once did believe that God exists, but now find yourself doubting? What if you class yourself as being an atheist or an agnostic? Over the next 25 minutes or so, we're going to explore together why a belief in God is both rational and logical by looking at some of the arguments and evidences for the existence of God. My own belief in God is not down to blind faith. I have a background in science and mathematics. I have a skeptical mind. I question what I'm told. I don't just accept the evidence of God simply because I was brought up in that way. I don't accept the evidence of God just because my family accepts it. My own belief in God requires more than that. Think about this exchange of text messages. Do you believe in God? Yes. What's your evidence for a belief in God? My belief in God isn't based on evidence. There's more to it than that. Really? Do you believe in the Easter Bunny? No, don't be daft. Why not? Because there's no evidence for it. Exactly. Oh. And our belief isn't based on just blind faith. We don't believe in God just because someone told us about God or someone told us that we should believe in God. Needing evidence for a belief in God is not a sign of weak faith. When Thomas had doubts about the resurrection, Jesus provided the evidence for him. He didn't berate him or belittle him for his need for evidence. Seeking evidence is not a bad thing. Refusing to accept it is. As Paul writes in 1 Thessalonians, "But examine everything carefully, hold fast to that which is good." Those who have beliefs should not be scared to test them. Those who don't have a belief shouldn't be scared to test their unbelief. We're going to look at 2 of my favourite arguments for the existence of God. The first of these is the cosmological argument. And the cosmological argument is a deduction from the existence of the universe to a first cause. And deduction is a form of argument where the conclusion necessarily follows on from the premises if the argument is valid and sound. The classic example is as follows. Premise 1, Socrates is a man. Premise 2, all men are mortal. The conclusion, Socrates is mortal. And the argument is valid because there's no contradictions, there's no circular reasoning. And the argument is sound because both premises are true, and therefore the conclusion is true. The cosmological argument is conventionally stated like this. Premise 1, the universe has a beginning. Premise 2, everything that has a beginning has a cause. Conclusion, therefore the universe has a cause. And this argument is valid. It's the same form as the Socrates examples. There's no contradictions. There's no circular reasoning. But is the argument sound? Are the premises true? And it's not surprising that until recently, the universe was thought to be essentially static and unchanging in time. In 1929, Edwin Hubble, after whom the Hubble Space Telescope is named, discovered that the universe was expanding. And this didn't fit in with what Einstein thought was happening. And like Einstein, 3 scientists called Bondi, Gould and Hoyle were unhappy with the idea implied by Hubble's observation that the universe is expanding. And they created a theory which was called the steady state theory. And the theory stated that as the universe expanded, new matter was created in the widening gaps between the galaxies. The theory was published in broad terms in 1949 and a mathematical account of the theory later the same year. In 1965, however, microwave background radiation was discovered. This radiation is the same in all directions. And there wasn't any way in this steady state theory to explain why this radiation was there. Based on astronomical observations, physicists made calculations tracing the expansion of the universe back to the first few moments of the universe. And right now, the earliest moment that scientists talk about occurs at 1 times 10 to the power of minus 43 seconds, i.e. 0.00043 zeros and then a 1 after the initial moments of the Big Bang. And this is what's known as the Big Bang theory. And although the Big Bang theory is famous, it's also widely misunderstood. A common misperception about the theory is that it describes the origin of the universe. And that's not quite right. The Big Bang is an attempt to explain how the universe developed from a very tiny, very dense state into what it is today. It doesn't attempt to explain what initiated the creation of the universe, or what came before the Big Bang, or what lies outside the universe. And another misconception is that the Big Bang was some kind of explosion. That's not accurate either. The Big Bang describes the expansion of the universe. Its name arose, it was given in kind of a derogatory way by a scientist who didn't agree with the theory. The Big Bang theory wasn't very popular amongst scientists because they thought it laid open the doors to religion. One reason for initial resistance to the Big Bang theory was that, unlike the rival steady-state hypothesis, it proposed that the universe had a beginning, a proposition that for some had unwelcome religious implications. Andrei Zanadav, Stalin's chief ideologue, in a speech given in 1947, describes the scientists who were chief proponents of the Big Bang theory as falsifiers of science who want to revive the fairy tale of the origin of the world from nothing. So the Big Bang theory was not readily accepted to start with because the implications for religion it had. Going back to the premises of the cosmological argument, the first premise seems to be universally accepted. In a lecture entitled The Beginning of Time, Professor Stephen Hawking said all the evidence seems to indicate that the universe has not existed forever, but that it had a beginning about 14 billion years ago. And the second premise is also generally accepted. It's our experience that things don't come into existence without a prior cause. In fact, the whole of the scientific enterprise is based on the principle that things have causes. And it has been objected that electrons can disappear and reappear in another location, but it seems that these electron fluctuations are not uncaused, but depend on the fluctuations in the surrounding vacuum. So as both premises appear to be true, the argument is sound. Therefore, the conclusion is true. The universe has a cause. And what can we say about that cause? Well, it has to be something outside of the universe, doesn't it? i.e. outside of space and time. So immaterial and eternal, something that's ageless, something that's always existed. It has to be something with the power to cause the Big Bang and thus create the universe. And the only thing that fits all of these characteristics is God. And if you're in a questioning mood, and I hope you are, you should be thinking, okay, God created the universe. Where did God come from? And logically, we've got two choices. Either God has always existed, or something or someone created God. And if we take that second choice for a moment, if something created God, who or what created that thing? And again, we have two choices. Either that thing has always existed, or something created that thing. And if we take the second of those choices again, it goes on forever, doesn't it? Allegedly, a well-known scientist once gave a public lecture on astronomy, and he described how the Earth orbits around the Sun, and how the Sun in turn orbits around the centre of a vast collection of stars called our galaxy. At the end of the lecture, a little old lady at the back of the room got up and said, "What you've told us is rubbish. The world really is a flat plate supported on the back of a giant tortoise." And the scientist gave a superior smile before replying, "What's the tortoise standing on?" "You're very clever, young man. Very clever," said the old lady. "But it's turtles all the way down." And the expression turtles all the way down is used to express the concept of infinite regress, that something must depend on something else, which must depend on something else for infinity and for infinity, forever and ever. And by definition, this can't exist. So the only option is that God has always existed. And God being eternal, God being everlasting, God having always existed is of course something that the Bible explains. Psalm 90 verse 2, before the mountains were born, or you gave birth to the earth and the world, even from everlasting to everlasting, you are God. Your throne is established from of old, you are from everlasting, that's Psalm 93. And in Deuteronomy 33, we read, the eternal God is a dwelling place. So that's a brief summary of the cosmological argument. The next thing I want us to have a look at is the teleological argument, and specifically at the anthropic principle. And they're fancy words, aren't they? Put simply, the teleological argument just says that if things look like they are designed, they probably are. And anthropology, we've heard of that word, it's the study of humans and society. The anthropic principle explores how the universe seems to be just right for human life. So much just right that it looks as if it had been designed that way. The term was first used by an astrophysicist called Brendan Carter in 1974, and an awful lot has been written about it. Another astrophysicist called Paul Davies wrote a book about the anthropic principle, but named it the Goldilocks Enigma, why the universe is just right for life. And that's a name that perhaps we understand a little bit better. We all know the story of Goldilocks. We know the story of the three bears and how Goldilocks tries the 3 bowls of porridge and sits on the 3 chairs and lies down on the 3 beds, but each time it's only baby bear's porridge or chair or bed that's just right. The image here is the Crab Nebula, part of space that was first observed clearly in 1731 by an English astronomer called John Bevis. Discoveries in physics and chemistry and cosmology suggest that the existence of a stable universe providing an environment that can sustain complex life is a remarkably delicate phenomenon. It's becoming increasingly clear from mathematical models and computer simulations that the formation of galaxies and stars and planets depends on many physical constants having very precise and very carefully coordinated values. The astrophysicist Paul Davies puts it like this: if almost any of the basic features of the universe, from the properties of atoms to the distribution of galaxies, were different, life would very probably be impossible. Many physicists and astronomers have been struck by the surprising nature of the findings. The Nobel Prize-winning physicist Arno Pentsiev, one of the discoverers of the cosmic microwave background radiation, reacted like this. Astronomy leads us to a unique event, a universe that was created out of nothing and delicately balanced to provide the exact conditions required to support life. In the absence of an absurdly improbable accident, the observations of modern science seem to suggest an underlying, one might say, supernatural plan. And the theoretical physicist and mathematician Freeman Dyson, who's famous for his work in quantum field theory and solid-state physics and astronomy and nuclear engineering, stated that as we look out into the universe and identify the many accidents of physics and astronomy that have worked together to our benefit, it almost seems as if the universe must in some sense have known that we were coming. We're not going to look at the nature of our particular local environment on planet Earth, which make it ideally suited for life forms such as ourselves, because it could quite easily be argued that, well, we're here, we've adapted to fit the conditions that we have on the planet. Instead, we're going to focus on much more fundamental considerations relating to the possibility of life of any kind existing anywhere at all. Paul Davies sets out very clearly some of the necessary conditions for life to exist. To permit life at least one place in the universe, 3 basic requirements must be satisfied. The The laws of physics should permit stable, complex structures to form. The universe should possess the sorts of substances, such as carbon, that biology uses. And an appropriate setting must exist in which the vital components come together in the appropriate way. And we're going to have a brief look at each of those in turn. The laws of physics are currently understood in terms of four fundamental forces: gravity, electromagnetism, the strong and the weak nuclear forces. And all of these forces working together in a delicate balance seem to be necessary for stable, complex structures to form. One writer puts it like this: if gravity did not exist, masses would not clump together to form stars or planets. If the strong force did not exist, protons and neutrons could not bind together, and hence no atoms with atomic number greater than hydrogen would exist. If the electromagnetic force didn't exist, there would be no chemistry. And as we begin to develop our understanding of these fundamental aspects of nature, we can get a clearer and clearer picture of what would happen if the strength of these forces or the relationship between them were very slightly different. For example, it's now thought that the process of nuclear fusion going on inside of stars is reasonably well understood. Stars are held together by gravity, and the pressure exerted by gravity squeezing it all together on the interior leads to the production of energy by the breakdown of the atoms. The force of gravity is extremely weak compared to the electrical forces that bind atoms together and keep them from collapsing, which is why stars have to be enormously large in order to begin to exert enough pressure on the atoms at their centre to start the nuclear furnaces burning. However, the formation of a stable nuclear furnace, such as our own sun, that's able to burn for billions and billions of years and supply the constant source of energy that sustains all life on Earth, requires a remarkable coincidence between the strengths of the forces involved. And Paul Davies puts it like this: an alteration in, say, the strengths of the gravitational force by a mere 1 part in 10 to the power of 40 would be sufficient to throw out this numerical coincidence. In such a world, all stars would then either be blue giants or red dwarfs. And the number that Davies gives, 10 to the power of 40, is scientific notation for 1 followed by 40 zeros, or in other words, 10,000 billion, 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 billion. If 1 in that massive number was changed, it wouldn't work. And it's the discovery of this astonishing level of precision in the balances between the forces that is needed to form such fundamental structures as stars that has raised the puzzle for scientists to explain. The laws of physics also attempt to describe the properties and the behaviour of the fundamental particles that make up the material world. All of the matter that we have been able to directly detect and investigate, including the matter that makes up the Earth and ourselves, consists of atoms of a few dozen different types, known as the chemical elements. And these atoms, in turn, are made up of more fundamental particles known as protons, neutrons, and electrons, and they, in turn, are made up of even more fundamental particles. We're not going to worry about them. Each of these fundamental particles, the protons, the neutrons, and the electrons, has a property, its mass, which determines how the force of gravity affects it and how it will react with other particles. And protons and neutrons each have around 2,000 times as much mass as an electron, but roughly the same mass as each other. And it's becoming clear that these exact values of the masses for different fundamental particles and the relationships between them are crucial in determining the overall composition and the properties of the matter in the universe. For example, there's a very slight difference between the mass of a proton and the mass of a neutron. A neutron has around 0.1% more mass than a proton. So tiny, tiny differences. And remarkably, it seems that this small difference needs to be very precisely set to allow the universe in order to develop the complex material structure at all. If the mass of a neutron was 0.2% higher than a proton instead of 0.1%, then protons wouldn't be able to form together to produce deuterium, so stars wouldn't be able to use the hydrogen to release energy. fusion in stars works by hydrogen combining together to form deuterium. On the other hand, if the mass of a neutron was slightly closer to the mass of the proton, then almost all of the hydrogen would be rapidly converted to helium almost instantly, and the lifetime of the stars would be drastically reduced. And stars play a significant role in the second basic requirement for any form of life that we've listed: the production of the sorts of material substances that can be used to produce complex life. In the current scientific models of the universe, all of the chemical elements, apart from hydrogen and helium, are thought to have been formed in the nuclear furnaces of the stars. Hydrogen atoms are fused together in these reactions to form helium, and then helium atoms are fused together in processes that lead to the heavier elements, including all of those that make up the planets such as Earth and complex life forms such as ourselves. There's a major problem though with forming elements in this way. When two helium atoms fuse together to form beryllium, the result is very unstable and it will fall apart almost as soon as it's formed. This seems to allow little opportunity for a third helium atom to become fused in order to create carbon. You might remember from school days, helium has got two protons. When two of them fuse together, we get something with 4 protons. If another 2 can fuse with it, you then get an element with 6 protons, which is carbon. And nobody could see how to make the process of nuclear fusion in stars sort of mathematically create any significant quantities of the heavier elements such as carbon and oxygen, until the physicist Fred Hoyle suggested in 1954 that there might be a remarkable coincidence in the properties of carbon and oxygen. And he suggested that the nuclei of carbon atoms might have a special excited state at a very specific energy level that corresponds to the energy level of the beryllium nucleus plus a helium nucleus. And he also suggested that oxygen would fail to have this same kind of excited state. You might remember from school science that oxygen has 8 protons, so carbon's got the 6. We can't then sort of very easily add another helium to that to produce the 8 in the same way that carbon is easily produced. He suggested that oxygen would fail to have the same excited state at the relevant energy level, which would explain why all the carbon that was produced wasn't sort of immediately converted into oxygen. And until quite recently, this was all just supposition and theory. It couldn't be proved in any way, it was just theoretical physics. But more recently, his predictions have been borne out by experiments, becoming one of the first examples of the use of the anthropic principle to understand the properties of the natural world. And a more recent study in the journal Science has confirmed that small changes in the result of the strength of the electromagnetic force of the source would eliminate the delicate balance and result in virtually no carbon or oxygen production in the stars. And the science writer John Greben and the astronomer royal Martin Rees write, "This combination of coincidences, just right for resonance in carbon-12, just wrong in oxygen-16, is indeed remarkable. There is no better evidence to support the argument that the universe has been designed for our benefit, tailor-made for man." And although Fred Hoyle remained a firm atheist all his life, he said, "I do not believe that any scientist who examined the evidence would fail to draw the inference that the laws of nuclear physics have been deliberately designed with regard to the consequences they produce inside stars." The final component, the final requirement that astrophysicist Paul Davies listed was that an appropriate setting must exist in which the vital components come together. Despite initial resistance from some atheist scientists, the Big Bang Theory has been accepted as a reasonable description of the history of the universe by the majority of scientists today. The idea of the whole universe expanding from a tiny beginning several billion years ago and developing as it expands so that the stars and the planets come to be formed and life comes to emerge on at least one planet is now widely presented in popular scientific accounts. And what's not often stressed, but is becoming steadily more appreciated by cosmologists and astronomers studying these phenomena, is the fact that this model only works if we introduce some remarkable fine-tuning in the basic constituents and the initial conditions. Cosmologists refer to the density of the universe as ohm, that little Greek symbol. The value of ohm is absolutely crucial. If the universe emerged from the Big Bang with a density that was just a tiny bit too high, then it would have been pulled together too strongly by gravity, and it would have collapsed on itself, and there would have been less of a Big Bang and more of a big crunch. On the other hand, if the density were too little, just a tiny bit too low, then the expansion would spread the material of the universe too thinly for galaxies and stars to form together or for any interactions at all. And both of these are runaway processes. If the density is too large, it gets rapidly larger and larger and larger as the universe collapses. If the density is too small, it rapidly gets smaller and smaller as the universe spreads out. However, the Big Bang model suggests that we're now 13.7 billion years away from the Big Bang, and the universe clearly contains very many stars and galaxies. This implies that the value of the density at the beginning must have been very close, indeed to the critical just right value, which is denoted by setting ohm as 1. And John Gribbin puts it like this: in order for the universe to have lasted that long, but not to have spread itself so thin that stars and galaxies could not form at all, the value of ohm in the first second after the beginning must have been very close indeed to 1. In fact, any deviation from 1 must have been smaller than 1 part in 10 to the power of 15, so 1 with 15 zeros on the end. And there are so many other values within the universe that have to be just right. Andrew's talked in the past about how the planet Earth is just the right distance away from the sun, how the relative mass of the moon and the Earth means that the tides exist that keep the oceans flowing, but they're not so strong that the world is destroyed by the oceans, and lots of other things as well. The best current scientific theories of the universe seem to require the strengths of the fundamental forces and the properties of the fundamental particles to be very precisely chosen in order to allow a complex, stable universe to exist at all. Moreover, the Big Bang model only describes a universe with complex structure if the initial conditions, including the overall amount of matter and its distribution, are specified with enormous precision. In a book by Stephen Hawking and Leonard Lodinoff, they write, "Our universe and its laws appear to have a design that's both tailor-made to support us and, if we are to exist, leaves little room for alteration. This is not easily explained and raises the natural question of why it is that way." And Stephen Hawking is trying to come up with theories to explain this. He doesn't like the idea that it points to a God, it points to a creator. But when we look into the Bible, it's easy for us to see why it is that way. Isaiah writes, "For this is what the Lord says, the one who created the sky. He is the true God, the one who formed the earth and made it. He established it. He did not create it without order. He formed it to be inhabited." We read in the Psalms, "The heavens are telling the glory of God, and their expanse is declaring the work of his hands." In Romans 1 we find Paul says, "For since the creation of the world, his invisible attributes, his eternal power and divine nature have been clearly seen, being understood through what has been made, so that they are without excuse." For me, the two arguments that we've looked at, the cosmological argument and the teleological argument, provide a compelling case for the existence of God. I want to leave you with one final quote from Robert Jastrow, a self-proclaimed agnostic. "For the scientist who's lived by his faith in the power of reason, the story ends like a bad dream. He's scaled the mountains of ignorance, he's about to conquer the highest peak. As he pulls himself over the final rock, he's greeted by a band of theologians who've been sitting there for centuries."